This is problem number 4 from section 9.4. And this problem is say solve the linear system by using Gauss-Jordan elimination method. So Gaussian elimination, in Gaussian elimination, we got the bottom left 3 zeros and then the middle ones down the diagonal. But we left these ones up here as just whatever numbers they were. Gauss-Jordan, we're going to get the bottom left to be zeros and the top right to be zeros. I actually did Gauss-Jordan in the very first problem of this homework section, even though I was only supposed to do Gaussian elimination, but I'm just leaving that. So we want to get ones down the diagonal, zeros everywhere else. That's Gauss-Jordan elimination. So we're going to start by writing our augmented matrix. Our augmented matrix is 1, 2, 0, 0. And then we have 1, 3, 1, 1. And we have 5, negative 1, negative 1, negative 1. Okay, we're going to start. I usually like to start in the bottom middle. I'm actually going to start with the middle row this time. So I'm going to take negative 1, R2. That's automatically going to make this negative 1, negative 3, negative 1, negative 1. We got 1, 2, 0, 0, and 5, negative 1, negative 1, negative 1. And I'm going to take row 2, row 1, plus row 2, and that's going to equal, I was trying to save some space, equal row 2. Row 1, row 2 equals row 2. So that's going to give you 0. We'll write the first one, 1, 2, 0, 0. I'm going to write the top row just so I keep this straight. Got kind of a lot of work to do here. So 0, negative 1, we do 2, negative 3, 0 and the negative 1 gives you negative 1, and 0, negative 1 gives you negative 1 as well. And we have 5, negative 1, negative 1, negative 1. Now I'm going to get that bottom row by taking negative 5, row 1, and that's going to be negative 5, negative 10, 0, 0. 0, negative 1, negative 1, negative 1, 5, negative 1, negative 1, negative 1. All right, let's take row 1 plus row 3, and that should equal row 3. So as we do that, we're going to take negative 5, add it to row 3, that's row 3, so we're going to have 0, negative 11, negative 1, negative 1. 0, negative 1, negative 1, negative 1 here. Negative 5, negative 10, 0, 0 there. Now we're going to go for a 0 down here. How can we get it? We got to use the middle row. So we're going to multiply the middle row by negative 11. Negative 11 R2. And that's going to give you 0, 11, 11, 11. And we're going to get 0, negative 11, negative 1, negative 1, negative 1. On top we got negative 5, negative 10, 0, 0. We're going to take row 2 plus row 3. That's going to equal row 3. We'll try and save some room so we can get it all in there. We're going to get 0, 0, 10, 10. Perfect, got it in there barely. This is 0, 11, 11, 11, and negative 5, negative 10, 0, 0. Now we're going to go through and we're going to get this up here, this negative 10. We want this negative 10 to essentially be 0. We want this to be 0 and this one to be 0. Before we do that, let's just reduce this down by taking negative 1/5 times row 1. So that's going to be 1, 2, 0, 0. Let's do the same thing with the middle row. So we end up with 1/11 R2. So we're going to get 0, 1, 1, 1. And let's do 1/10 on the bottom. That's 0, 0, 1, 1. Sometimes I like to take them down to smaller numbers so we can easily see what we need to do next. And now you can see that we need to get this to be -2. So let's go -2, R2. And we're going to get 0, -2, -2, -2. And we're going to have 0, 0, 1, 1. And we've got 1, 2, 0, 0 on top. We need to add row 2 plus row 1, and that's going to change row 1. And that's going to give you 1, 0, -2, -2. And in the middle row, I'm actually going to take that back to what it was originally. So at the same time, I'm going to do -1/2 times row 2. So -1/2 times row 2 will give you 0, 1, 1, 1. And we have 0, 0, 1, 1. All right, now we're going to have to slide up a little bit. I think we should be able to get this on this last row. I need to take the bottom row now, and I need to cancel this first row right there, and I also need to cancel that middle row. So I got 2 operations I need to do there. Let's change all these to the same number, and then we can do it at the same time. What do you think about that? So we're going to do, I'm going to multiply this row here by -2 and this bottom one by 2. So -2 R2, and we're going to go 2 R3. So when we do that, we end up with 0, 0, 2, 2 on the bottom. We get 0, -2, -2, -2. And we have 1, 0, -2, -2. Now I'm going to take row 3, add it to row 1, and it'll be row 1. But I'm also going to take row 3, add it to row 2, and it's going to be row 2. So I'm going to kill a couple birds with the same stone. Start with the top. We're going to get 1, 0, this cancels and this cancels, right? 2 and -2, so it's 0, 0. We're going to do the same thing with this middle. So it's 0, -2, cancel and cancel. And then the bottom row is still 0, 0, 2, 2. Last step, we're going to do -1/2 R2, and we're going to do 1/2 R3. So we end up with 0, 0, 1, 1, 0, 1, 0, 0, and 1, 0, 0, 0. Notice we have the identity matrix here. That tells us x is 0, so we have x is 0, y is 0, and z is 1. So our ordered triple that we get it from this is 0, 0, 1, and that's the solution. I hope that makes sense.